Hello everyone, this is the second part of the gravitation chapter, class 9th. So the next thing which we have to study, that is the free fall. What is this free fall? Simply, free fall can be defined as when a body falls from a height towards the earth only under the influence of gravitational force, then the body is said to have a free fall. No other forces should act on the body except the gravitational force. If the body is falling towards this earth, okay, only under the influence of the gravitational force, that is the condition for the free fall, and the body having a free fall is called a freely falling body. So we are seeing here in the figure that vacuum is created by removing the air from the glass jar, and whatever the feather and the coin is there, it is falling simultaneously, okay, on the other side, the ground. So whatever the situation is there here, it is the situation for the free fall. It means only the gravitational force is acting, and this was proved by the Galileo, that the acceleration of an object falling freely towards the earth, it does not depend on the mass of the body, it is independent of the mass of the body. Next, whatever the acceleration which is produced due to the gravity, what is this acceleration due to gravity? First of all, it is represented by small g. We had studied about universal gravitational constant, that was represented by capital G, but here it is small g, that is the acceleration due to gravity. So acceleration due to gravity is defined as uniform acceleration produced in a freely falling body due to the gravitational force of the earth. In other way, we can also say it that whatever the acceleration which is produced in any freely falling body due to the gravitational force, that is the acceleration due to gravity. And its mathematical value is, that is small g is equal to 9.8 meter per second square. So how we got this acceleration due to gravity, the mathematical value of this acceleration due to gravity, or what the formula of it is? Let us see that. So suppose any body is there of mass small m, which is placed on the earth of mass capital M, and they are separated by a distance, that is their radius, that is r. So according to Newton's universal law of gravitation, whatever the force which is exerted by the earth on the body is given by F is equal to g m, that is capital M into small m, by r square. This force exerted by the earth produces an acceleration also in the body. Whatever the force which is applied by the earth on the, that is small body, which is represented by small m, okay, it produces an acceleration. So that is, from that we can simply write F is equal to mg, where small g is acceleration due to gravity. So this F is equal to mg is derived from that same formula, that is F is equal to ma. So there for acceleration we were using small a, and here for acceleration we are using small g. Both are same thing, just whatever this acceleration is, it is produced due to the gravity. That is why it is represented by small g. So from both the equations, we can write that mg is equal to gm into m by r square. Now concluding ahead, we can write as small g is equal to capital G into capital M upon r square. That is g is equal to gm by r square. So if we are knowing the gravitational constant value, the mass of the earth and the radius of the earth, we can calculate the value of small g, which will come 9.8 meter per second square. Next thing is the mass of the body, the mass and weight. The topic is mass and weight. So both are quite different. Let us see that what is mass and what is weight of the body. First of all, the mass of a body is the quantity of matter contained in it. How much amount of matter is there in any particular body? That is the mass of the body. So we can simply say that mass of the body can never be zero. Along with that, if the mass of the body means amount of quantity of matter is more, so we can say that yes, the mass of the body is a measure of inertia of the body. It is a scalar quantity and its SI unit is kilogram. Another most important thing is that mass of the body is constant and it does not changes from place to place. It never changes. Whatever the mass of your body is there on the surface of the earth, it will remain same on the moon also. But if we are talking about the weight, that will definitely change. We will see ahead. Next, coming to the weight, that what is the weight? So weight of a body on the earth is the force by which it is attracted towards the earth, towards the center of the earth. So weight is simply a force. So if it is a force, and we have studied the formula for force, that F is equal to mg, so we can write W is equal to mg, because we have defined here, we have explained here that what is weight. Weight is a force. So W is equal to mg is another formula. SI unit of weight is Newton, which is represented by capital N, and weight of 1 kg mass is 9.8 Newton. Along with that, it is a vector quantity. We are always aware about the direction of the body whenever we are calculating the weight of the body. It changes from place to place, yes. Whatever the weight of your body is there on the earth, it will not remain same on the moon. It will become 1/6. So weight of the body changes from place to place. Mass never changes. Mass is constant. It is measured by spring balance, and this weight of the body can be zero, because we know that whenever a body is taken to the center of the earth, acceleration due to gravity at the center of the earth is zero. So whatever the weight of the body is there at the center of the earth, okay, is zero. So weight of the body can be zero. Thank you, everyone.